Okay guys, using a trigonometric identity, and now we are getting to the points in the lesson where this should be new for everybody. I did not cover this in class. This is kind of where we took a step back, bell rang, we all left class. I was planning on doing this when we all got back, and then schools went to online learning. So everybody should be starting here. Everybody needs to know what's going on using a trigonometric identity. So it says, consider the figure, and by the figure I mean the kind of like part circle thing with the triangle in it, where the point xy is on a circle of radius 1 with the center at the origin. So I only took kind of like the first quadrant over here. The green line should be a whole circle, so picture it going the whole way around. And then remember they're talking about a radius, and a radius is always from the center of your circle to the edge of your circle versus a diameter, which goes the whole way through. And they're telling you that the radius is 1. Then we have this point over here. The point is x comma y. So keep in mind the way you plot a point is you go over x and you go up y. And that's where they're coming up with that. Also, if you look at that triangle, do you notice that it's a right triangle where it comes straight down and hits the x-axis? So the first thing we're going to look at is we're going to look at the sine of theta. And if you notice on your picture, they put theta right here, so that's our reference angle. So in our triangle, we can label the sides of that triangle. 1 is going to be your hypotenuse, y is going to be opposite from theta, and x is going to be your adjacent. Just for a reference, I'm going to write SOHCAHTOA up here. And if you take a look at sine of theta, sine is O over H. So on that triangle, O, your opposite side is Y, and H, your hypotenuse, is 1. So that's going to give us the ratio of Y over 1. Then I want you to think about that and go, okay, well, Y over 1, anything divided by 1, same thing. So the sine of theta would just be Y. Cosine of theta. AH, adjacent over hypotenuse. Adjacent side, x, hypotenuse, 1. X over 1. Same thing. Anything divided by 1, just x. So the cosine of theta, x. Tangent of theta, TOA, O over A. So opposite over adjacent, y over x. Now, for the time being, that's really all I want you to know. But if we want to go back and reference just a little bit, y over x. Well, y. Didn't we say y up here was really the sine of theta? So, sine of theta over x. Well, didn't we say right here x is the cosine of theta? Cosine of theta. Another way of writing your tangent. So, by the Pythagorean theorem, now I want you to go over here. I want you to look at this triangle again, right? If you're using the Pythagorean theorem, can you do a squared plus b squared equals c squared? So I'm thinking x squared plus y squared equals 1 squared. What do we know about 1 squared? Well, that's just 1. So, x squared plus y squared equals 1. Then we're going to go make some substitutions. So we've got x squared plus y squared. Well, x. Look back up here. What's x? Isn't x the cosine? So, cosine squared theta. Now I know that looks funny, but when you're squaring a trig ratio, instead of writing like cosine theta squared, we don't do that because I don't want theta squared. I really want this whole thing squared. So option 1 is you can kind of put it in parentheses like that and put the squared outside. But most people don't like option 1, so they go with option 2. And you take this little squared thing and you stick it right between the cosine and the theta. So x squared is the cosine of theta squared, which is written as cosine squared theta, plus y squared. Well, if I go back up here, look at y. Isn't y just sine theta? So, same thing. We're going to take sine theta and square it, but the way that's written, oh no. Where's my undo button? There it is. Is sine squared theta equals 1. And what you guys just figured out here is a very, very, very important Pythagorean identity. So, next page, the Pythagorean identity. The equation cosine squared theta plus sine squared theta equals 1. There's the identity you just figured out. Is true for any value of theta. In this section, theta will always be an acute angle, meaning less than 90 degrees. A trigonometric equation that is true for all values of the variable for which both sides of the equation are defined is called a trigonometric identity. Because of its derivation above, cosine squared theta plus sine squared theta equals 1 is also referred to as the Pythagorean identity. And the reason for that, they said derivation, is because we got it by using the Pythagorean theorem. We started with a triangle and we got it. Now, again, in secondary math 2, I need you to know this. We're going to use it on 2 more examples. But the real key here comes in when you guys are in AP Calculus, when you guys are in a trigonometry class, and next year when you take secondary math 3.